Hello learners, in this video we will be discussing about what is open loop and closed loop control system and how to analyze the mechanical system. Now, in our previous video we learnt that how to define system. What is system? System is the typical arrangement of components connected together to perform a specific function. That is system. Okay, so typical arrangement of components, collection of components together to perform a function, that is system. But what is control system? How to define control system? Control system is a system which directs the input to other system and regulates their output. That is control system. Control system is nothing but a system which basically controls the variable of main system, variable of the other system or a main system. It may be a mechanical system or electrical system or electronics, hydraulic, pneumatic. It may be a plant. So it may be anything, any system in which one particular variable, it may be a temperature, pressure, humidity, flow, level, any variable, it may be a variable. To control the variable, we need a system called control system, right? So most often this may be called as a controller. Control system is a controller, have the input called reference input. Reference input is the desired input. Actual desired input means what you want to control. Suppose if you want to control a particular variable in a system to particular value, right? That value is the reference input, and the output of the control system is a controlling signal which is given to the system to regulate the variable output of the system. That is the idea. So we know what is system and what is control system, right? Now let us discuss in detail about the how to implement the control in a system, right? Say for example, let us consider example of a system is a bicycle, mechanical system. Let us consider a mechanical system for some main system as maybe a bicycle, right? So we know that definition for a system is desired typical arrangement of components connected together to perform a function. So in a bicycle we have lot of mechanical components, chain drive, two wheels are connected through chain drive, and gear arrangements and handbar, pedal, right, everything. So these are all connected in a typical arrangement, in a proper sequence together to perform a function, dedicated task. The function can be performed by the bicycle is to move, right? To using bicycle we can displace from one place to other place, right? So it produces displacement. So basically for a bicycle, input is a force. We apply the force on the pedals and the two wheels rotates and the bicycle moves in a linear displacement. Okay. So the input is force, output is displacement. So bicycle is a mechanical system. Okay. When you apply the force, you will get the displacement, right? Now, what about the control system for the bicycle? So if I want to control, now let us select the variable in a bicycle. When I drive the bicycle, the variable may be a speed. Let us consider the variable as speed. That means I want to drive the bicycle in one particular speed. Let it be a 10 kilometer per hour, right? So for driving the bicycle 10 kilometer per hour, I have to give the force, assume that I have to give 200 newtons force, right? So when I give 200 newtons force on the pedals of the bicycle, it moves, it runs 10 kilometer per hour speed. Okay, fine. Now the assist thing is, what about the control system, controller? So now when I am driving the bicycle, I am the controller, human controller, I am the controller. I want to drive the bicycle in 10 kilometer per hour and I apply the 200 newtons force on the pedals. Now the bicycle runs on 10 kilometer per hour. Okay. But when the when driving the bicycle, lot of disturbances may come to reduce the speed. Like there may be a speed breaker on the road, and there may be a suddenly somebody may cross the bicycle, and I have to apply the brake. Naturally, speed reduces, right? So also there may be the road conditions may be very poor, so we cannot maintain the speed 10 kilometer per hour. We have to reduce the speed. So like that, there may be any disturbances may be due to any source, like speed breaker, somebody crossing, or road conditions, anything. Because of that, we cannot maintain the 10 kilometer per hour speed, so speed reduces. But now the thing is, when after the disturbance, I cannot maintain the 110 kilometer per hour speed, because I don't know the present speed, right? Because of the disturbance, the speed is reduces. Now the present speed, if I don't know the present speed of the bicycle, how can I control it? Whether I don't know whether I have to increase the speed, how much I have to increase, that and all I don't know. So for that, but anyway, I am controlling. That means my desired speed is 10 kilometer per hour, and I apply the force, right? So I am the controller, human. My input is desired speed. The speed is 10 kilometer per hour. So accordingly I have to apply the force on the bicycle. I am applying the 200 newtons, for example, and bicycle runs on 10 kilometer per hour. But after the disturbance, speed reduces. But now in this situation, I cannot maintain the speed, because in this situation, this control system is called as open loop control system, right? That means I'm not the output and input is not connected. Output is not giving any information to the input. Okay, so the controller gives the control signal to the bicycle only based on the desired speed. That's all. So I'm keep on 200 newtons per newtons force, then I cannot maintain the speed. Okay. So in this situation, it is a open loop system, but it is a control system, open loop control system. I am able to drive the bicycle to particular speed, but after the disturbances come, I cannot maintain, because of it is open loop. That is the point I want to say with this diagram. So let us see one more example. It may be a air conditioned system in a room, right? And there may be a controller. Now the input to the controller is desired temperature. So assume that I want to maintain the room temperature 200 degree, 20 degree Celsius. Okay, suppose I want to maintain a room temperature as 20 degree Celsius. That is my desired temperature, and accordingly the controller will give a signal to the system, air conditioning system, to maintain the temperature as 20 degree centigrade room temperature. Okay, right. That means air cooling system is operated based on the desired temperature. Now after the room temperature is set as 20 degree, now assume that some people are entering into the room. Now room temperature will slightly increase, right? Slightly increase. In this situation, we do not know the present room temperature. So suddenly the room temperature may decrease as 18 degrees, something like that. but we do not know the present temperature because there is the output is not connected with the input, no feedback. Hence, in this situation, it is a open loop control system. Okay, it is a control system, but in open loop, right? We are not able to maintain the control whenever, even after disturbance comes. That is the problem in an open loop control system. But it is an open loop control system. We are able to control the variable. Okay, that's all. Then how to solve this problem? To rectify the problem, we need a feedback element. That is, output should be connected to the input through the feedback element. Now there is a loop exists. The closed path is a loop. Closed path exists between the input and output. Input may be called as R of t, output may be called as C of t, right? And R for reference. Okay. Now reference input and output are connected through feedback element. Now what is the situation? Even after the disturbance comes, you will be able to maintain the reference value, your desired value, right, because of the feedback element. So this is called closed loop control system. So here the system to be controlled is a plant. It may be a plant or a system. Here only we are going to control some variable, right? And the controller may be a control system which actually controls the main system, right? So controller is the control system which controls or regulates some variable in a main system. Okay, right. Now the situation is, this is closed loop control system. See how does it work? So your desired reference value is given to your reference value is given to actually sub ordered or subtracted with the feedback signal, right? So let us when it is ordered, it is called positive feedback. When it is subtracted, it is called negative feedback. Now let us consider here in this, you can see the negative symbol. So it is a negative feedback. So the reference input will be subtracted. The feedback signal will be subtracted from the reference input, and the result is called error. So error is the difference between the reference input and the feedback signal. That is actually given as a input to the controller. Okay, but in the open loop control system, reference input is given as an input to the controller. Reference input is given as input to the controller, but here the difference between the reference input and the feedback signal, that is error, is given as an input to the controller. That is the difference between open loop control system and closed loop control system. And again, the output of the controller, it's called manipulated signal or controlling signal, which is given to the system. And now the output of the system is again sensed by the feedback element and given to the reference input, and we are able to control the C of t to the reference value R of t. So the objective of this closed loop control system is to maintain the reference input when the to maintain the reference input R of t, okay, as C of t. C of t should be equal to R of t. When it happens, when your error becomes 0, right? So the error should be a 0. If there is error, it will be corrected by the controller. That is why it is called as control system. The error will be, the objective of the controller is to make the error 0 and make the output C of t is equal to R of t. That is the closed loop control system. Now let us discuss some example. Example 1, the same example, bicycle. So bicycle is a system and speed is a variable I want to maintain, right? Say my desired speed may be 10 km per hour, and controller is a control system. If it is a human, it is a human manual control. If it is some circuitry or some control system, then it is a automatic. Okay, it may be the controller may be a pneumatic controller, hydraulic controller, or electronic controller. It may be a computer, it may be a microcontroller, whatever it is. Now the controller is a control system. Now let us see, for in this example, let us consider the manual control system. So say for example, I am driving a bicycle and my desired speed is 10 km per hour. Okay, so I have to give, assume that I have to give 200 newtons force on the pedals of the bicycle to drive the bicycle into 10 km per hour, right? So to drive the bicycle in 10 km per hour, I have to apply 200 newton force on the pedals. Now I am applying the 200 newtons and the bicycle is running on 10 km per hour. Okay. So now what is happening is, there may be some disturbance due to the road conditions or the speed breaker or somebody is crossing. I am applying the brake, the speed reduces. Now we have the feedback element, speedometer. Speedometer showing the speed, current speed. So it is indicating the current speed is reducing, right? So after the disturbance comes, it shows that the speed is something 8 km per hour. But actual my desired speed is 10 km per hour. So what is the difference? 2 km per hour. That is error, right? So the error is nothing but the difference between our actual desired speed, reference input, minus the feedback signal, okay, present speed. So the difference is error. So here in this example, 10 km per hour minus 2 km to 8 km per hour is equal to 2 km per hour. So now the controller have to take the decision it has to increase or decrease the output manipulating signal to make the error 0. That means to make the speed, output speed 20 km per hour, sorry 10 km per hour. Okay, right? So நம்ம desired speed வந்து 10 km per hour. இப்போ டிஸ்டர்பன்ஸ்னால இப்போ கரண்ட் ஸ்பீடு வந்து 8 km per hour. அப்போ டிஃபரன்ஸ் வந்து எரர் வந்து 2 km. ஸோ இந்த எரர், இந்த 2 km பவர் எரரை வந்து குறைக்கணும். தட் மீன்ஸ் controller has to increase the speed. Okay, error may be a positive or negative. When there is a depends on the sign of the error, controller output will increase or decrease. Here in this example, controller have to increase the speed, right? So desired speed 10 km, actual இப்போ இருக்கிற ஸ்பீடு 8 km. ஸோ டிஃபரன்ஸ் 2 km per hour. ஸோ கண்ட்ரோலர் என்ன பண்ணணும்னா இந்த 2 km per hourங்கிற எரரை வந்து 0 ஆக்கணும்னா ப்ரெசன்ட் ஸ்பீடை 8 km 10 km ஆக்கணும். 10 km per hour ஸ்பீடுக்கு கூட்டணும், right? That is the job of the controller. So now controller will increase the manipulating signal. அதாவது மேனிப்புலேட்டிங் சிக்னல் இஸ் அ ஃபோர்ஸ். அப்போ இப்போ கண்ட்ரோலர் வந்து ஏற்கனவே 200 நியூட்டன்ஸ் கொடுத்துட்ருக்குன்னா இப்போ வந்து டிஸ்டர்பன்ஸ்னால அந்த ஃபோர்ஸை குறைச்சிருக்கும். இப்போ எகைன் அந்த ஃபோர்ஸை வந்து கூட்டணும், இன்க்ரீஸ் பண்ணணும். ஓகே, ஸோ அப் டு 200 நியூட்டன்ஸ் வரைக்கும் இன்க்ரீஸ் பண்ணணும். ஓகே, ஸோ நவ் when the controller increases the force on the pedal, so now I am the controller, I am increasing the force on the pedal but I am not measuring the force, I am measuring only the speed pedal. And now the bicycle will start, the speed of the bicycle will start to increase, right? And the speedometer is showing that 9 km per hour. So my desired speed is 10. Error is becoming reducing. Earlier error was 2, now the error is becoming 1 km per hour. Again I have, so the controller again it has to increase the manipulating signal. So again I am increasing this force. Now the bicycle speed also again increases. Now the speedometer is showing 10 km per hour. My desired speed is also 10 km per hour. So the error is 0. Once the error is 0, controller should not take any action. It has to maintain the same force. Okay. Now the bicycle will be running on the 10 km per hour, same speed. So this is how we are able to maintain our desired speed with the help of feedback element. In this example, feedback element is a speedometer because we are trying to maintain the speed. So speed sensor or speed indicator is the feedback element. So this is the one example of a closed loop control system. And another example in the previous air conditioned system, in the open loop we can close the loop by connecting a temperature sensor, right? So in this example my desired temperature may be 20 degrees Celsius and the controller is trying to maintain 20 degrees Celsius. Somebody is entering onto the room, some people are entering onto the room temperature slightly increases, becoming 22, assume that it is becoming 22 degrees Celsius. Again now the temperature sensor senses the present temperature is 22. Actually desired temperature is 20. So the error is 2. So the controller have to take that action to reduce the error as 0. That means it has to decrease the temperature by making more cooling. Okay, air conditioned system. Now what will happen? Suppose now the air condition, the controller reduces the temperature. Now the present temperature sensor sensing and showing that the 20 degrees Celsius, the the reference temperature is also 20 degrees Celsius, error is 0, then controller maintains it. Okay, so that is how the closed loop system works. It's also called feedback control system, right? Because of the feedback only we are able to control the variable, control the desired value, right? Then it is called feedback control system, right? It's a closed loop control system or a feedback control system. Now let us analyze this closed loop control system mathematically, right? See, in this control system subject, our objective is to analyze the system behavior by mathematical description, by developing the mathematical model, right? Okay, that we will discuss later in detail, but here let us analyze the closed loop control system or a feedback control system to find the gain. Okay, say for example, let us analyze the system. Let us consider this example here. Anyway, this from input to the output we have a controller, system and feedback element, right? The closed loop control system, controller, system, feedback element. So the controller and the system is in a forward path, and feedback element is in a feedback path. So the overall gain by the gain of the control system and the actual system, let us call it as G. Okay, இப்போ இந்த கண்ட்ரோலர் இந்த சிஸ்டம் இது ரெண்டும் சேர்ந்து, இந்த கண்ட்ரோலரோட கெயின் சிஸ்டமோட கெயின் ரெண்டும் ஒரே பாத்தில் இருக்குது, கேஸ்கேடிங்கில் இருக்கிறதுனால அதை ஜாயின் பண்ணிக்கலாம். ஸோ மொத்த கெயின் வந்து ஜின்னு வச்சுக்கிறோம். இட் இஸ் கால்டு ஜி ஃபார் கெயின். அண்ட் ஃபீட்பேக் எலிமெண்ட்டில் இருக்கிறதோட கெயினை வந்து ஃபீட்பேக் எலிமெண்ட்டோட கெயினை வந்து ஹெச்னு வச்சுக்கலாம். லெட் அஸ் கால் த ஃபீட்பேக் கெயின் அஸ் ஹெச் அண்ட் ஃபார்வர்ட் பாத் கெயின் as G. Okay, so that is what shown here. So the G here, G refers to the gain of the controller and the system, and H refers to the gain of the feedback element. Okay, fine. Now I told you that the feedback can be a positive feedback or negative feedback. So now let us analyze the negative feedback first. So in this example you can see that R is the reference input, B refers to the feedback signal, and E refers to the difference between R and B, error. Okay, and error is given as the input to the controller and the system. The overall gain of the controller and system is G, and controller output is C, let it be C, and it is given as the input to the feedback element. Gain of the feedback element is H, the output of the feedback element is B. Okay, so that is the scenario. Now let us analyze this. Let us find the gain of this simple loop. Now the output of the loop is C. Okay, now how can the C can be written as G into E, right? So in the இதில் பார்த்தோம்னா G block ஓட output வந்து C, overall block ஓட output வந்து C, and input of the forward path வந்து E, error. So error is the input to the forward block, okay, forward path G. So output is C. C can be written as G into E. Okay, C can be written as G into E. But we know what is E. E is nothing but E is a error, difference between R and B. So E can be written as R minus B. It is a negative feedback. R is given to the plus input, B is given to the minus input. So E can be written as R minus B. So in this expression E replaced as R minus B. So C is equal to G into R minus B. So this can be written as, again, now what is B? B is nothing but output of the feedback element. So input of the feedback element is C. So B can be written as C into H, right? So the output is nothing but input into gain. So B is nothing but C input into gain H. So B can be written as C into H. Okay. Now manipulate this expression, C equal to GR minus GCH. Okay. It is very simple mathematics. Now our interest is to find out the overall gain. Overall gain is, overall output is C, overall input is R. So overall gain is output by input C by R. We need C by R from this expression. Okay. Now what? Bring this GCH to the left of the expression. We get C plus CGH equal to GR. Right? And it can be written as, in this left side of the expression, C is common, take the C out, 1 plus GH equal to GR. So overall gain is C by R. So bring the R to the left side and bring 1 plus GH to the right side of the equation. So you get C by R equal to G by 1 plus GH. Okay. So the overall gain C by R of the feedback path, feedback control system, negative feedback control system is C by R equal to G by 1 plus GH. Right. Now let us consider the positive feedback. When R is given, B is also positive input, R is also positive input. Now the E is nothing but R plus B, right? Now the same method way you can derive the expression. C can be written as E into G, right? And E can be written as R plus B. Earlier we wrote R minus B, here R plus B. Now it can be, B can be written as, B is nothing but C into H. Okay. B is nothing but G into H. So GR plus GCH. So bring the GCH to the left side, we get C minus GCH equal to G into R. So C take the C common in the left side, C into 1 minus GH equal to GR. So C by R overall gain equal G by 1 minus GH. Okay, so that is the overall gain of the positive feedback. Now observe that the overall gain of the negative feedback system is G by 1 plus GH. Overall gain of the positive feedback system is G by 1 minus GH. That is the difference. Now this feedback, because of the feedback element, when you connect the feedback between the output and input, it becomes the closed loop system. Because of this connecting feedback, what about the effect on gain? In the negative feedback, gain decreases, and in the positive feedback, overall gain increases. Right? See, in the negative feedback, overall gain decreases. Why? Because GH is a positive value. So when it is positive, 1 plus something is positive. So it will, so G, open loop gain, G divided by some positive value will reduce the gain. But here 1 minus GH, so that means it will increase the overall gain. Okay, so the negative feedback, the gain is reduced, whereas in the positive feedback gain increases. That is the effect of the feedback on the overall gain. Because the gain reduces in the negative feedback, we call it as a degenerative feedback. Degenerative feedback. Whereas in the positive feedback, as gain increases, the output of the system will keep, output of the overall output will keep on increasing with respect to time. Then it is called as regenerative feedback. Okay, regenerative feedback. And the stability we will discuss in later, what is stability in detail. But because of the feedback, negative feedback, system becomes unstable when GH is equal to minus 1. Right? See here, in the negative feedback overall gain, substitute GH is equal to minus 1. What do you get? So G by 1 minus 1 is nothing but 0. So gain will become infinite. So gain becomes infinite means system is unstable. Gain infinite na output vandu very high, not bounded output. So it is unstable. But in the positive feedback, when you put GH equal to 1, the system becomes unstable. So both the negative and positive feedback, you can make the system as a stable by selecting the proper value of for G into H. Okay, so negative feedback system, for the negative feedback to be stable, GH should be plus 1. For the positive feedback system to be stable, GH value should be minus 1. That is the concept. Okay, now so far we discussed, we understand what is closed loop system and how does it differs from the open loop system. Okay, so our next we will be discussing on mechanical system. Let us analyze one particular type of system. It is a mechanical system. Okay, we will be discussing in the next video. Thank you.